for questions such as this, I like to actually draw the curve and try to see what we're talking about here. So in this situation, the curve is just our normal bell curve. And I apologize, by the way, I'm drawing this with my finger. I haven't bought a stylus for this yet, but I think it's going to be more helpful to see it. So we have the curve, and instead of knowing a z-score this time, we know the percent, and the percent is 5%. So somewhere over here, we're talking about the bottom 5%. And this is given away by the fact that it's talking about the cumulative area. So instead of percents in this problem, it's talking about an area of 0.05. So when we say cumulative, we mean building up from left to right. So starting over at negative infinity all the way up to some z-score, which we'll label right here, 5% of the data would fall, or an area of 0.05. So our goal is to find that z-score. Whenever we have areas or probabilities and we're looking for z-scores, this is the inverse of what we were doing in the last section. The last section we had z-scores and we were looking for probabilities, we would use normal CDF. So doing the inverse of that now, we use something called inverse norm. So in the calculator, you're still going to go to second and vars, except this time, and I'm doing this on my calculator off to the side, this time option 3 says inverse norm. And the way the inverse norm function works is when you click on that, it's going to set up a parenthesis, and all you have to do is put the cumulative area from the left to the right into that parenthesis and hit enter. So when I do that, 0.05, and I hit enter, it gives me a value of negative 1.6448, which rounded to the nearest hundredth would be negative 1.65. So that's the way it's done using the inverse norm function in the calculator. It's a lot easier than using the tables. However, while I'm making this video, I might as well show you the other types of things that can show up. So another way show up is I could ask something once again with the normal curve, but instead of talking about the bottom 5% or the bottom 50% even, I could say something like, what z-score, so I'm looking for this z-score that separates the upper, and it doesn't really matter what number we use, let's say 25. So here I know the area, or the probability that I'm talking about, is the upper 25%, or the area at the top that is 0.25, and I want to know the z-score. The problem with this is when you use inverse norm in the calculator, it only reads from left to right. So if I put 0.25 in the calculator, this would be the wrong thing to do. If I inverse normed 0.25, my calculator would think I was talking about the value that separates the bottom 25%. I want to make sure that's not a z-score, that's up there, 0.25. So the calculator is not going to be able to read it the way we were doing for the last problem. So instead, if the calculator only reads from left to right, I just need to enter this area that I'm shading in red now. And that's pretty simple to find, because if we know the area at the top is 0.25 and the total area underneath the curve is 1, then 1 minus 0.25 tells me this has an area of 0.75. So to actually get the value, once again, of this z-score that separates the upper 25%, I need to inverse norm 0.75. And once again, I apologize by the childish looking writing here. And when you inverse norm, so that's second distribution again, and we go down to option 3, put in 0.75, it's going to give us a z-score of 0.67. So I hope this actually helps you with the entire section, not just the one problem you were asking on, and shows you how you can do this in the calculator a lot easier than using tables. Hope this was helpful. Good luck.